guys, I'm just going to go over the review with you. So um, if you would like, you can just go with the key if you already feel comfortable, but if you need a little bit of help, you can watch this video. All right, and then I will post a test tomorrow, by the way. Okay, determine whether the following are polynomial functions, and if they are, state the degree. So remember, in order to tell if a function is a polynomial function, we need to look at the exponents on the variables. If all of the exponents on the variables are whole numbers that are positive, then it will be a polynomial. So here I'm looking at x. There's no exponent, which means it would be a 1. The exponent on this would actually be outside the parentheses. So because both of the exponents here are just positive ones, this is a polynomial. Now it says if it is a polynomial to state the degree. So remember, the degree is just the number of times that x is being multiplied together. So in this case, I have 1x here and 1x here. Those will be multiplied together, and so the degree here is 2. Now in this next question, this is written in a different form than the first one, right? Number 1 is written in factored form. Number 2 is written in what we call standard form. So there's a little bit different technique of how to find the degree depending on which form it's written in. So because this one's in factored form, I just count up how many times x is being multiplied together. But if it's in this standard form, I just look for the highest exponent. Because all the exponents on x are positive whole numbers, then yes, this is a polynomial function, and its degree is also 2. Okay, so when they're multiplied together, count how many times x is getting multiplied. That's the degree. If it's in standard form, just look for the highest exponent. Number 3 is not a polynomial because the exponent on x is 1/3. If it is not a polynomial, you do not need to state the degree. On number 4, we have 1 over x. So this doesn't look right away like x has a negative or fractional exponent, but remember that you can write 1 over x as x to the negative 1 power. That's the exact same thing. So this would not be a polynomial. Anytime x is in the denominator, it will not be a polynomial because that's the same as having a negative exponent. Here on number 5, all of the exponents are positive whole numbers. So yes, this is a polynomial. It's in factored form, so I have to count up how many times x is getting multiplied together. X minus 3 cubed, remember that means take x minus 3 and multiply it out 3 times. So that for this one, I'll have 3 x's being multiplied together. There's another one, 4, and this one, 5. So the degree here is 5. So basically, we're just adding up all of the exponents. If I don't see one, it's a 1. So 1 plus 3 plus 1. All right, so let's move down. So find all the zeros and state their multiplicities. So remember, well, a couple of things. First of all, in order to find the zeros, this needs to be in factored form. So we have to make sure that they're in factored form before we start looking for zeros. So like 6, 7, and 8, I can just write down the zeros and their multiplicities. Number 9 is not in factored form, it's in standard form. So before I can find the zeros for that one, I'm going to have to factor it. So remember, to find the zeros, you just take each factor individually. So I have one factor here of x, one of x minus 3, and one of x plus 2. So these are the 3 factors that I want to set equal to 0 and find the zeros. If I set x equal to 0, there's really nothing to solve, right? Our 0 would just be 0. And because there's just one x out here, it has no exponent, it would just be multiplicity 1. So I don't really need to write the multiplicity on that one, although it wouldn't hurt to write multiplicity 1. On the second one, we have x minus 3. If I set that equal to 0 and solve for x, I would add 3 to both sides. So our x would be 3. Let's do x equals 0, x equals 3. Because this one is raised to the 3rd power, the multiplicity for that 0 would also be 3. I'm just looking at the exponent, that's the multiplicity. For this one right here, the third one, x plus 2 equals 0. I would subtract 2 from each side, so my 0 is negative 2. Again, no exponent means it's just one of them, so the multiplicity would not, I wouldn't have to write it, it would just be 1. On number 7, I have a 4 out front. Since there's no x with 4, I can't really set it equal to 0, right? It makes no sense to say 4 equals 0, right? 4 is just a constant, it's not going to change my zeros. So you only need to worry about those single things out front if they have a variable with them. So x minus 5 would give us a 0 of 5, and because it's to the 4th power, it would have a multiplicity of 4. X, x plus 16 would give us a negative 16, and it would have multiplicity 2, excuse me. All right, on number 8, we have this 5x squared out in front. So because that one does have the x, we would need to set that one equal to 0. So 5x squared equals 0. If I divide both sides by 5, I'm going to get x squared equals 0. And if x squared equals 0, then x has to be 0. So anytime you have that singleton without a plus or minus, you're going to get x equals 0 as long as there's an x there. So x equals 0, because it's squared, it will have multiplicity 2. And then for 3 minus x, I would need x to be equal to positive 3, right? Because 3 minus 3 is 0. And for x plus 2, it would be negative 2 multiplicity 7. So I've been very consistent. Sometimes I'm writing x equals, sometimes I'm not, but we just want to point out the zeros and what their multiplicities are, so it doesn't really matter. On number 9, we need to get this in factor form. So we're going to use x factoring. So a is 1 if I don't see a number in front. So up here, remember, goes a times c, so 1 times negative 8. Down here, we need b, so that would be 7. And then I'm looking for two numbers that multiply to negative 8 and add to 7. So that would just be a positive 8 and a negative 1. And then I would write them here. So x plus 8 times x minus 1. I would normally divide those by a, but because a is 1, it's not going to change anything. So my two zeros I can now see are negative 8 and positive 1, both multiplicity 1. Okay. Now we're on number 10 through 13, we're asked to go back the other way. So previously we were asked to look at the polynomial and find the zeros. Now we're given the zeros and we're asked to find the polynomial. So basically I had x plus 8 times x minus 1. The zeros were negative 8 and 1. Now I'm given those zeros and I need to put them back in that factored form. So if I have a positive 3, I know that must have come from a factor that looked like that, x minus 3. We're going to be multiplying them all back together here. There's 3 of them. There's a 5, which means the factor would have looked like x minus 5, and the negative 2 would have been an x plus 2. Now it says to put number 10 in standard form. So all that is asking us to do is multiply this back together so that we can get it in that standard form that looks like number 9. Number 9 right here. So when you have 3 binomials, remember a binomial is just a polynomial with 2 terms. When you have 3 that you need to multiply together, you start by multiplying just the first 2. So I would just go ahead and multiply that part out. That would be x squared, and then minus 5x, and then minus 3x, and negative 3 times negative 5 would be plus 15. So if I simplify that by combining our like terms right here, that will give me x squared minus 8x plus 15. Now I would need to take that and multiply it by x plus 2. So x squared times x gives me x to the third. X squared times 2 would give me 2x squared. Negative 8x times x gives me negative 8x squared. I'm just going to stack it here with the like terms so I can add them up easily at the end. Negative 8x times 2 would be negative 16x. 15 times x would give me 15x. And then 15 times 2 gives me 30. So now I'm just combining all the like terms. So I'm going to put a line under here. So I've got x to the third. 2x squared minus 8x squared would give me negative 6x squared. And then negative 16x plus 15 would give me negative x, and then plus 30. So this is the same polynomial as that, but this one is in standard form. So see how the degree is the same. If I count up the number of x's that are getting multiplied together when it's in factored form, when I've got it in standard form, that's going to be the highest degree. Okay, For number 11, if I just have a 0, I know there's going to be just an x. For 7, that'd be x minus 7. 4 would give me x minus 4. And negative 3 would give me x plus 3. So we don't need to put all of them in standard form. It just asks us to put number 10 in standard form. Number 12, my 0 is negative 2, so that would look like x plus 2. The multiplicity is 3, which means that would be to the third power. And then for 4, we would have x minus 4 squared. On number 13, I have a 0 of 0, which again is just an x. It would be the same as like x minus 0 or x plus 0. We don't need to write that part. To the fourth multiplicity, so the fourth degree, times x minus 6 to the third degree. All right. Moving on. So number 14, we have a lot of parts here. Hoping I have enough room to write. Okay, so part A says list each 0 and its multiplicity. So the 0 here is negative 3. And its multiplicity is 2. Part B says to determine whether the graph touches or crosses at each x-intercept. So remember, if the multiplicity is even, then it touches. So that's this number. If that number is even, it touches. So this one will touch. Touches at negative 3. And if it's an odd multiplicity, so if the multiplicity or the exponent on this would have been 3 or 5 or 7, then I would know it would cross at that one. Part C says to find the y-intercept. The y-intercept can always be found by plugging 0 in for x, so it's finding f of 0, which in this case would be negative 0 plus 3 squared. To replace x with 0, that would be negative 9. So that's where it's going to cross the y-axis. Part D says to find to sketch the graph. Well, let's put that over here. So the intercepts are what I want to put on first. So remember, the zeros are the same as intercepts. So I know that there is an intercept here at negative 3. I know that this needs to cross the y-axis at negative 9, so down here. And I know that the degree of my polynomial is 2, right there. So it has an even degree, which means both ends are going to go the same direction, normally up. But because of this negative right here, that's going to flip both of these so that they go down. So I know that both of the ends are going to end up down. That's going to be the end behavior. So I know it's going to come from this end up, and it's going to come either touch or cross at each x-intercept. There's only one x-intercept here, and it touches. So I know it's just going to come up, and it's going to touch and turn around. It's going to come back down and go through our y-intercept at negative 9. Wow, I'm making a mess. Just got a few extra lines here. And that end will end up down also. So basically it's just, since it's squared, it's a quadratic, so it's a U shape that looks sort of like. Alright, so I'm running out of time in this video, so I'm going to go ahead and stop this one, and then I will do these last two questions and page 2 on a second video. Alright.